of a point from a line. This is, we have a coordinate system in which this represent x-axis and this line represent y-axis. This is a non-horizontal and non-vertical straight line L. Also, this is a point P having coordinates x1 and y1. We have to find the distance of this point P from a line, this line. So it means we have to find this distance. Let me represent as D. Now this is a P and we have drawn a perpendicular PQR on OX. And from this P we have drawn a perpendicular PM on the line L. This is a point Q with coordinates x1, y2. This is abscissa and this is ordinate. Since the ordinate of this Q is y2 and this point is also passing through this line, so the equation of this line would be A x1 plus B y2 plus C is equals to 0. So this was the all construction. We are only interested in this side as we have to find the distance of the point from this line PM. This is, we have angle alpha, and if we have to find a side which is adjacent to angle, we always use angle cos. And when we have to find a side which is opposite to angle, we always use sine angle. Since in this diagram, in this particular theorem, we have to find a side which is adjacent to this angle, so we will use cos. It means cos alpha. We have to find the value cos alpha. Now cos alpha is equals to PM over PQ. But we have to find the side PM. So we will take PQ to the other side of equality and we have PQ cos alpha is equals to PM. So it means that we have to find the value of cos alpha and PQ so that we can put it in this form and get the result, which is this theorem. So first we will write the construction of this coordinate system. So the equation of the line is ax1 plus by2 plus c is equals to 0. As we have to find the distance, so we can write the sign of absolute, because the sign of absolute is used to find the distance. So first we will find this distance PQ. This distance PQ. We have the coordinates P x1, y1 and q x2, y2. Okay. So to find the distance, we have the formula d, the distance of PQ. It is found x1 minus this is, we have the x2 second value whole square plus y1 minus y2 whole square. So this is the formula to find a distance. So this is x1, this is x2, this is y1, this is y2. So the value of x1 is x1, the value of x2 is again x1 plus the value of y1 minus the value of y2. So this will be cancelled out and we have y1 minus y2 whole square and the sign of square root. So square root will be cancelled out with this square and we have the value of PQ, which is equals to y1 minus y2. We can write it in the form of mod since it is a distance. This is y1, this is y2. Now to calculate this y2, we can use the equation of the line, which is ax1 plus by2 plus c is equals to 0. From here we can separate out the value of y2. by2. Now we will divide minus b throughout the equation. Minus a over b x1 minus c over b, which is equals to, this will be cancelled out. So this is y2 minus a1 minus c over b, or we can write it in a combined form, minus x1 minus c over b is equals to y2. So this is, we have the value of y2 also. So we have found PQ. From here we can write also the slope of this line. This is y and this is, the slope is equals to, y is equals to mx plus c. So y is equals to, this is mx plus c. So the value of m is minus a over b, which is the slope of L. Okay, next we have to find cos alpha. Cos alpha, as cos is equals to, the base we have is this side, which we represented as B. This side we represented as A, which is perpendicular, and this is hypotenuse, which is equals to a square plus b square. As we know that if the base, we know base square plus perpendicular square is equals to hypotenuse square. So base is equals to b, perpendicular is equals to a, and this is equals to hypotenuse square. To find out the value of hypotenuse only, taking the square root and cancelling this square with the square root, here we have square root b square plus a square. So putting the values in the formula, base is equals to b over hypotenuse is equals to a square plus b square. So this is the value for cos alpha. Now we will put both of these values, let it represent as 2, this value of PQ as 1 in this equation, which we represented as A. Put all the values in A. A we have PM, which is equals to D. It is equals to PQ. So the value of PQ is y1 minus y2. y1 minus y2, and the value of cos alpha, which is this one, multiplication b over a square plus b square. Now d is equals to y1 minus the value of y2, this one. So this is y1 minus y2, multiplication with b over square root a square plus b square. Now d is equals to y1, multiply this minus side with this equation, we have minus minus plus ax1 minus minus plus c over b, and this will come as it is. Okay, now taking LCM, we have by1 plus ax1 plus c a square plus b square. Now writing this term in the form of separate mods. And b will be cancelled out, and we have d is equals to ax1 plus by1 plus c divided by a square plus b square. So this is the value of distance we wanted to prove.